In this video I'm looking at the solution to question 3 of the June 2011 Edexcel D1 paper, and the topic of the question is linear programming. The question refers to a figure which is the graph showing the constraints of a linear programming problem in X and Y, and R is marked as the feasible region. We're asked in part A to write down the inequalities that form that region, and then given that the objective is to maximize 3x plus y, we're to find the optimum values of x and y, making our method clear. And then in part C of the question, obtain the optimum value of the objective function. And then finally, given that the integer values are required for x and y, rather than those being any values, they have to be integers, we're now to write down the optimum values for x and y in that situation. So taking these one part at a time then, the inequalities that form region R, well, there are 4 of them on the diagram, as you can see. So let's look at these 4 inequalities. First one, if we look at the top line there, we have that 6x plus 5y is equal to 60 for this line, but we're lying below that. So we've got that 6x plus 5y must be less than or equal to 60. We have a line at the bottom, 2x plus 3y is equal to 12, and we're above that line. So that one is that 2x plus 3y is greater than or equal to 12. And looking at this one here, we can see that this is the line x is equal to 2y, but we want to be above that line, so therefore we've got that 2y is greater than or equal to x. And finally this line here where we've got 3x is equal to 2y, and we're below that line, so this time we've got that the 3x is bigger than 2y, or 2y is less than or equal to 3x. So 4 inequalities there for our region R, and the marking was to give B1 if there were 2 correct, and a second B1 for getting them all correct. The next part of the question says that we have to maximize the objective function 3x plus y. So we're going to look at the line 3x plus y, I beg your pardon, 3x plus y. So let's, for example, look at the line where 3x plus y is equal to 3. So that will go through 3 on the y-axis and 1 on the x-axis. So we could draw in a line on the diagram which goes through 3 and through 1. So this is our objective function here, and we need to mark that in on the diagram. So we could say this is 3x plus y is equal to 3, and then we need to move that line. So we're taking the line 3x plus y is equal to p and moving it away from the origin, and we're looking to maximize. So we want to find the final point that that line leaves the diagram, or the feasible region rather. So we can see, moving it just a little bit at a time, that the point where it leaves the feasible region is the one that's just coming up to there. So let's mark that on our diagram. This point here, this intersection, is going to be the maximum value. So the maximum value is given by the solution to those 2 line equations. So we've got where x is equal to 2y and where 6x plus 5y is equal to 60. So we need to solve these simultaneously. Well, that's relatively straightforward. Just substituting from the first equation into the second one, we get that a total of 17y is equal to 60, and therefore y is equal to 60 over 17 is one solution. And as x is equal to 2y, we get that x is equal to 120 over 17. And we can leave our answers like that. So there's our optimum solution. X is 120 over 17, y is 60 over 17. The marking for this part of the question was a method mark and an A mark, answer mark or accuracy mark for putting in a line on the diagram in the first place, and then what's called a dependent method mark. So as long as that line was clearly marked in, then we get a DM mark 1 for finding our maximum point by the solution to these two equations, and then finally an A mark for our solution for x and y. The alternative method of doing that would be to have tested each of these intersections. So you would have to find each one and show that the maximum value at each of those, to show that the point that we've found there gave us the maximum value for the profit. In part C, we've just to obtain our maximum value. So we know that P is equal to 3x plus y, and so substituting our values, that's equal to 3 multiplied by x, which is 120 over 17, plus y, which is 60 over 17. So in total there we get 420 over 17, and you could leave it at that. Finally, we're asked to find an integer value. So we're going back to our diagram then to look at integer values close to our maximum solution. Well, we can see that our best value is going to be at this point here. The integer value is at x equal to 6 and y equal to 4. The marking for those two parts of the question is simply B1 and B1. That completes the solution to this question. You can find solutions to other questions at www.furthermaths.org.uk.